Before heading to the video, if you haven't subscribed the channel, do subscribe it and don't forget to click the bell icon for the latest update notification. If you like the video, do like, comment and share. Stay tuned with learnbay.co. Happy learning!
So what is a generator? So generator, basically it is a sequence. Okay, generator is a sequence. Now when we say it is a sequence, so does it look like a list or a string or a tuple? So no. So how you can define the generator? Then you can define the generator. The syntax for defining the generator is similar to the function definition. Okay. For example, let's say I can write def my underscore generator, and here I will be writing, let's say I'm taking two arguments, a comma b comma c comma d. Okay, so what I will do, I will take these four numbers, and I'll take one list, LST. Okay, now for I in LST, what I will do, okay, so what I'm going to do is, so see here what I'm writing, yield. So what makes a function generator? So if you will have yield keyword, so yield keyword, having yield keyword in your function, that makes a function generator. Okay, now what is yield? Yield is similar to return statement. Okay, similar to return statement. Okay, now when you say similar to return statement, it means it returns the value. But why do we have then return and then yield also? So basically you may not write multiple return statement. Okay, for example, let's say I have a function in def1, and if I write return, let's say 10, and after that if I want to return another value after this, so only the first value will be taken. So for example, let's say if you will print f1, so it will be taking only 10. Okay, not the second return statement. So you may not write multiple return statement. Okay, but you may write multiple yield statements. I may write yield I into 2. Okay, so I'm writing two yield statements. Now let's say I'll create a generator object. You can create a generator object. So G is equal to the generator name which you have created. With the argument, I will be taking a list 11, 12, 13, 16. Okay, I'm taking this list. Okay, now you have created a generator object. If you will try to print G, okay, so it is going to give you the generator object. Fine, which looks like similar to the if you remember, reversed object or filter object or map object, or you can say sorted object, right? So it is similar to that. Now those all were the sequence. So if you want to get the value returned from this sequence or from this generator, then you have to wrap it around the list function. Okay, so if you will wrap it around list function, then you will get all the values which you are expecting from this sequence, right? So this is also sequence, right? Now, apart from this, what is the other way? So you have created a generator object. Now what you can do, you can print next of G. Keep on printing next of G. Okay, so you are getting 10 and 11. First value is 11, and then if you will print again next of G, so now this will print 22. Again, if you will print next of G, so let me print it 2 times. Now it will print 11, 22, 12, 24, right? This is giving all these values. Now let me write this. So you are getting till 18. Now I have to get till 19. So I will just write this 2. So I'm getting for all the 10 values inside this sequence. I'm getting all the values, right? So now this is called this is an iterator object. G is an iterator object. Okay. So whenever you create a generator object, this generator object is a sequence. Okay. And it returns a iter, double underscore iter, every table. So every sequence which you have seen till now, for example, if you have seen list, or if you have seen tuple, or you have seen string, bytes, byte arrays, whatever sequence you have seen, those all sequence internally, they have a function called iter. Okay, double underscore iter, double underscore. So whenever you create an table, or whenever you try to run a loop, for example, for I in LST, okay, so internally it returns one iterator object using this double underscore iter double underscore function. Okay, and with that iterator object internally it calls next function. Okay, whenever it will keep on calling next function. So let's say in the list, if you have 10 elements, so this next function will be called 10 times. Okay, and the values will be printed in the for loop. Okay, so what happens in that case, at the last, when all the 10 elements will be exhausted, and then again next function will be called, then it raises the stop iteration. For example, here all the 10 values are printed. So now if I'll call again next G, you can see here it is printing stop iteration. Why? Because I'm calling this next G function explicitly. This same next G function is called in the for loop also. Okay, but that next function which is getting called stop iteration is handled. This error is handled in the Python in for loop. Okay, so you don't get the stop iteration error when you run the for loop. Clear? Fine, everyone?
Yes, sir.
Okay, so that error is handled. Now, so do we have to call this next G function to get the element from this generator? No. So you don't have to do that. You can do this one also. You can call, you have 10 elements, so you can write for I in range of len of LST. Okay, and you can print next of
G.
LST. I have not defined. I have not taken LST. Okay, so let me take this LST. Okay, so you are getting all these values, but you are not getting it for all the 10 values. You are getting only for the only 10 yield statement you are getting. So for that, since you have 2 yield statement, so what you have to do, you have to multiply this by 2. If you will do, you will get it the same. Okay, one way is this. The other way to do the same thing is you can just go ahead and write for I in LST, and you can print I. So again, if you're running, you are getting the 10 values only. But if you want to get all the values, then see how it is done. First, we need to understand. Whenever you are running the loop, I in LST. Okay, so I in LST, I will become, sorry, not I in LST. I need to write G, I in G. Now, if you will run this, you will get all the elements. So when you are writing for I in G, I from here, this loop will go inside this generator, and it will run this loop. So I will become first element 11. Now it will yield the I. So I will become 10. Now after that, it will come back to this, this value, and again it will yield I into 2. So I into 2 is what? 22, 11, and then 22, not 10. 10 was this value. So let me remove this. So you have 11 and then 22. Okay, then again it will go back to the loop. I will become the next element. So this generator, how it runs, whenever you are printing I, like whenever you are running the loop, it is going into the generator. Okay, whenever you are running this loop, it is going into the generator. Okay, now So for I in G, once you are running, it will go inside this. For I in LST, it will pick the first element, okay, and it will yield I, okay. Since these all are the block of code, these all things will be executed, okay. So it will yield I, and then it will yield I into 2, and then after yielding I into 2, it will go back to the loop again, and it will keep on printing the value, okay. So this is how the generator sequence is executed. Now let's say I have a simple generator. One more generator I will write. So f my underscore gen. I can take the argument. You remember we have range function. So I will take start and stop. Okay. So what I want to do, I want to generate a sequence starting from this given value to this value. Okay. So what I will do, I will write while I will take one number I equal to, while I less than, okay, I will keep on yielding I. Okay, so I have generated this. Now what I will do, I will create a generator object G is equal to my underscore gen, and pass let's say 0, 10. Okay, so I will make this as, okay, so let's keep it as it is. Now what I will do, I'll run for I in G, and I will do print I. Now, so when you are going to run this loop, so what will happen? G is a sequence. It will go inside this generator. Where is this generator defined? Here. Now it will come here. I will become start. Let's say I is 0. Now 0 is less than stop, which is 10. Yes, true. So it will yield I. So when it yields I will become the value of I. What is the current value of I? It is 0. So it will print I on the screen. Then similarly, it will go back to this loop again. I will become the next element inside this. So for that, it will go inside the loop again. And here it will, so it has left here yield I, right? So it will go back, it will, okay, so we have to increment I also, I plus equal to 1. I will be incremented after this statement. I will become 1, and then 1 less than 10, yes, true. So it will yield I again. As soon as yields I, it comes out of the generator and then print I, so I value will be printed, which is 1. Okay, so again it will go back inside this loop, for loop. So I will become, I has to take the next element. Now it will go back to this yield statement where it has left, and then again it will execute the next statement. So I will become 2. Then it will go back and check in this loop, 2 less than stop, yes, true. So again it will yield I. So basically yield remembers its state where it has left last time. Okay, the significance of yield is it remembers its state where it has left last time. So if I will run this, so I'll get all the values starting from 0 to 9. Okay, fine. Now, how you can generate a generator? So this is one way of generating a generator, or using a generator, or creating a generator. You can use tuple comprehension also to create a generator. For example, if I write tuple is equal to, I will write, you remember list comprehension? Similarly, here I will write tuple comprehension. So I'll write I into I for I in range 10. If I'll print tuple, I'll get a generator object, okay, similar to this G. Okay, so what I can do, either I can type, I can wrap it around a list function, or I can, you can run the loop over it. Okay, so tuple comprehension also going to give you the generator. Similarly, this way also you can create a generator. Okay, now the next question is, so should we use, yes, Parini, any question?
Yes, sir. So when you say tuple object will create a generator, means this is equivalent to a yield statement, is it? It will always be like waiting for the next command to come in.
Yes, it is always like that.
Okay, so the way it will be read is for I is equal to, for I in range 10, next line, yield I square I. That's the way then we should read this.
I into I, yes.
Okay, okay, thanks.
Abhishek?
Yes.
I have a question on yield statement. To store the next value, where it is exactly stored?
Store the next value means?
So suppose you are generating the values using.
No, it doesn't stores the value. This is the advantage of the generator. Okay. So generator doesn't store the value. For example, that's what I'm coming to, that when we should use generator. Okay, whether we should use generator or sequence. Okay. So
to see the flow of the how it is working, can we debug this particular program?
yeah, you can debug it. You can debug it.
We need to install any tool for the same?
No, you just have Thorny editor. No, there you can debug it. Okay. PDB is there, but don't use PDB. Use, as of now, you use this Thorny editor. You can use, that will be useful, or you can use Python tutorial if you want to understand how it works. Okay. Fine. Okay. So let me do one thing. So first of all, this is the function definition. It is not going to first check whether, so it will take it as a function definition. It will not execute anything inside this. And since yield is there, so it will create a generator object. So if you'll see here, this is my underscore gen, and this is a, as of now, it is taking as a function object. Okay, now G is equal to this my underscore 0, 10. So G is pointing to a generator instance, which in turn, which is pointing to this my generation function. Now come to this for I in G. So when you are running this loop, so from here, it directly came inside this my underscore generation function. Okay, why? Because it has to define G. What is G? G is my underscore gen. Okay, now let's say if you have a list, so from here only it will pick the value, right? But if you don't have a list, you have a generator object, which has to go inside the generator. So now it is going inside the generator. I will become 0, and then 0 is less than stop, which is true. 0 is less than 10, and then it will yield I. As soon as it yields I, it will come out of the function. Okay, so after yielding I, it came here after line number 8, it printed I, which is going to be 0. It is on the screen, and then again you are going back to the loop is inside here. So again from here you are returning back to the line number 4, which is yield statement. So you left at yield statement, and then you are returning back there. Okay, so after this, again in the next line will be executed, I will become 1, and then again it will check the condition, yes it is true, then again it will yield the value of I, which is 1, and now it will print the value. So this process will keep on happening till all this this condition is satisfied. Okay, and finally once this condition is satisfied, it will come out of the loop. Okay, fine, clear? So you can run this here. You can run this in Thorny editor, and you can check the sequence how it is operating. But see, in which all cases we have to use this generator, or we have to use the normal sequence like list and all. So let's say if you will see what is the difference between list and generator sequence. So list basically what it does, list tuple, these all generators, they allocate the memory for the objects immediately. Okay, and you, let's say if you are running a loop over a sequence, you may not need all the elements inside that sequence, right, all the time, correct? Right, for example, when you are running the loop, you are accessing one value at a time from the sequence, right? You may not need all the values at a time. So let's say if you have trillions of data, or hundred or thousands of billions of data, then what will happen? Those all data will get allocated some memory into your system, right? So it is unnecessary. Most of the elements are occupying the memory unnecessarily because you are not using all of them at a time. Correct. So for that, in those cases, you can go for generator. For example, if I will try to show you, let's say if you have a list of range, if you will try to create a larger sequence using this, then it will give you overflow error. Why? Because it is trying to allocate the memory for all the objects starting from 0 till this number. Okay, so for allocating these many values in our memory, we don't have enough memory. right? So it is giving you overflow error. Whereas when you do the same thing with the range function, okay, you just do the same thing with the range function. So it will create the range object. Okay, it is not giving you any error. And even you can run the loop also on this for I in range. And if you will print I, it will keep on printing the value till till this number is generated last. Okay, why? Because see, this range is a generator, and first it has started from I equal to 0. It has yielded I 0, and then after that, when it is going back to the range generator object, it has forgot I equal to 0, so that it has lost the reference of 0, right? And then it will take 1. So next value it will take 1. So once you are taking 1, I is going to point 1 here, right? After yielding the next value, the reference to the previous value is lost. So that will be automatically garbage collected. So from time to time, you will be having your memory freed for use, right? So this is more efficient or more memory efficient, you can say, than normal sequence object generator. Clear? Clear, everyone?
Yes.
Yes.
Abhishek, cannot debug using Jupyter Notebook itself?
No, here we don't have, I think, the proper debugger. I have not used the debugger inside this. Okay.
Suppose if the Python file is high, if you want to nested functions, how generally it will be go on debug?
We have PDB module for that. Okay, we have built-in PDB module for that.
Okay, that is separate tool.
That is, yeah, you can say that is a different module, not required for you. Okay, fine. We are not going to cover that part here. So that again I will cover in the separate class, because there are different, that will take around 1 hour of discussion for that. So I'm not going to spend time there. Okay. If you want, you can read about, or you can learn about PDB. Okay. Okay. So